Assalamualaikum and a very good afternoon for those who have attended this WebEx session. Okay, I have give the link for the attendance. So for you guys that have entered this WebEx session, please fill the attendance first. Thank you.
Assalamualaikum, Dr. Faizal ada ke? Assalamualaikum, Dr. Faizal.
Dr. Afiq, are you here?
Ya. Attendance ada tak?
Dah bagi tadi. Okey, sekejap bagi lagi. Okay, for those who just join the Webex session, I paste again the attendance link, the Google form. Please fill in the attendance. Dr. Afiq, I text you personally the attendance link.
Okay.
So that after this, you can paste it. I will make you as a co-host after the opening. I just want to give some remarks and then you just handle the session, Dr. Afiq.
Okay, thank you, Dr. Faizal. You may proceed at this.
All right, now we have about how many participants? 99 participants. I think I shall start a brief introduction. All right, Assalamualaikum and a very good afternoon to all. The SSCG, SSCB, SETB, and other students, SKTK, and so on. Okay, actually we combine all the students from the Faculty of Science, Biology students, and also the students from SKT, School of Chemical Engineering, School of Chemical and Energy Engineering, SKT. So today we will have the experiment 2 session. Yesterday, for those who have attended yesterday, we have done the experiment 1. And then, as I told you, the session is all the sessions are compulsory for those who didn't perform the experiment yet, because we rotate the experiment during the lab session. Most of you have done, or I think all of you have done at least one experiment, and then you need to finish all others. Okay, for today we will perform the virtual lab for the experiment 2. Will be handled by Dr. Muhammad Afiq Muhammad Huri, and also Mr. Daniel, and also Dr. Aida. Dr. Aida, are you here? Okay. All right. So I have given the attendance link, and after this, Dr. Afiq will paste it again in the chat room, because some of you may just attend the session and cannot see the link in the chat room. All right. As I told yesterday, for those who have attended the lab session yesterday, you must prepare yourself with the lab manual. Okay. And then this session will be handled not in one way, like a lecture, normal lecture like that. We will have a two-way interaction. Okay. Dr. Afiq will, Dr. Afiq, Mr. Daniel, and Dr. Aida will pause the video, okay, and then ask you questions regarding the safety, technical question, and so on. All right. So you need to answer. Either you can open your mic or using chat, but we prefer you to open your mic. Okay, use your voice. Okay. And then after the lab session, I think for this experiment 2, Dr. Afiq will provide the simulation result for the data using the while the labs, the virtual labs happen, right? Not in the e-learning. Am I correct, Dr. Afiq?
Yeah, I will not provide the data after the session. So you guys need to take note the data for the experiment directly from the video that I will show to you.
Okay. So the data, okay, the result from this experiment, the titration result, will be given during this virtual lab lecture. Okay. So you need to be you need to pay your attention, okay, because you may use this data, this result, for your lab report. Okay, as I told you, the attendance will be considered as the logbook mark. Okay, so please attend all the session that you haven't done yet for the experiment. Okay, that is compulsory. Right, and then without further ado, I would like to pass the session to Dr. Afiq, Mr. Daniel, and Dr. Edta. Please, Dr. Afiq. Thank you.
Okay, Assalamualaikum everyone. I think we should wait until 2:30 because right now on my clock is 2:27. So we will wait for another 3 minutes before we begin our session. Okay, again, I will attach again for the person that's just entered the session, the attendance link. Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. Okay, maybe we open our session with the Ummah Kitab and your own style of prayer. Okay, hi everybody. I would like to know if we have any international student over here. Do we have any international student yourself? Okay, yes, doctor. So, Al-Zahra Muhammad, are you an international student? Where are you from?
Doctor, I'm from Egypt.
Egypt. Okay, so I'm trying my best to deliver everything in English.
Thank you, Doctor.
All right, no problem at all. Okay, so I will just open the video. Where is it? Share first screen. Share my screen. Share video. Okay. Okay, can you guys see the blue screen over here? Alisa Najwa, can you observe the blue screen? Any of you?
Yes, doctor, we can see the blue screen.
Okay, so I will play the video. If you didn't hear any sound, please tell me as soon as possible. Okay, today we will learn about the experiment number 2, which is the complexometric titration, okay, for determination of calcium. Okay, I believe you guys already have the manual with you. So maybe some of you can guess what is the importance of this study. Can anyone provide any guess why we need to learn this particular experiment? What is the benefit of this experiment? What is actually the experiment is trying to do? Can somebody guess? To check the quality of water. Okay. Okay. Farah Hashim said that determine the water hardness. Okay, what is mean by water hardness? Can anybody guess? The presence of calcium salts. Okay, that is the thing that we want to study. Okay, we want to determine the amount of calcium. Okay, but what is mean by the water hardness? You can Google, and then you can share with us. Maybe I would like to. Yeah, sorry.
Doctor, is it the concentration of the metal ions in the water? For example, the magnesiums and calcium, so on.
Okay, thank you, Lim. Need to open the chat on my another monitor. Yeah. Lim said that we want to look at the amount of the metal ions. Is correct. Okay. Water hardness is about the dissolved mineral in the water. Okay. So as the amount of minerals or the amount of the metal ions increasing in the water, so the water hardness become much higher and higher. Okay. So what happened when the water hardness level is high? Can anybody guess? For example, calcium. What happened if the amount of the calcium in the water is so high? What is the disadvantage or advantage of it, if any? Because we need to know the importance of this study, why we're doing it in the first place. Okay. Why we need to study about the water hardness. Okay, maybe I would like to call randomly. Okay. Haziq Hasnizam. Oh, somebody already given the answer in the chat. Okay, very good. Okay. Okay. Haziq Hasnizam, are you here with us?
Yes, doctor.
Okay. So why do you think we need to study about the water hardness?
Sorry?
What is the importance of this study? Okay, what is, maybe we can guess the disadvantage of the water hardness in our daily life. I think some of the answer is already described in the chat. Maybe you can try to read for us. Okay. Haziq, are you here? Okay, it's okay. From Lam Boon Hui, he said that the poor soap and detergent performance. Okay. What happened when we are not carefully remove the calcium from the water? Okay, right from the what we call water source. Okay, so the problem we may have the poor soap and detergent performance at our home. Okay. Okay. For example, from the Syarikat Air Johor, they processing the water before it reach to the domestic house, for example, our house. Okay, if we not treated carefully the amount of mineral, okay, so the amount of mineral will cause several disadvantage. Okay, for example, okay, it may form clogs in our pipes, as is said by one Adian Lukman. Thank you. It can block water pipes, so when it coagulates inside there. And as the amount of water hardness increase, it will reduce the detergent performance. Okay, so when that happen, okay, usually when you wash your shirts, okay, so the amount of bubble, the amount of soap should be very much. Okay, but when we have the water hardness level is high, it will reduce that particular efficiency. Okay, so that's among the disadvantages of water hardness. So that's why we need to have this experiment to determine the concentration of the water hardness. Okay, is that the water hardness is exceed the amount, or it is actually under the what we call the max level allowed for the calcium to be exist in our water system. Okay, so that is the application of this experiment. Okay. So is there any question on it? Ada soalan tak? Is it harmful? For the time being, no. It's not really harmful if the amount is not that much. Okay, if just the current amount, I think it's okay. The calcium is actually the thing that we need to intake daily. So it's not harmful to be consumed. So it will produce other things. Basically, it should provide much more benefit to us if the amount of calcium is high in our water. But the problem is it will produce disadvantage on the other terms. For example, poor detergent performance, it will block water pipes. There is kind of the disadvantage we are not allowed to occur lah. Okay, so it's not harmful. Okay, so if there is no more question, okay, why we need to do this study? Okay, so as long we have understand the importance, I think we can proceed with the experiment. Okay, so I think whatever question that I asked you during the session, you guys need to have the consideration to include it in your report, because it's actually related why we need to do this study. Okay, let's proceed. You can stop me any time. Okay.
Hi, welcome to the experiment 2 of the complexometric titration for the determination of calcium in drinking water.
Okay, for the time being, can you guys hear the what we call the sound, the narration of the video? Yeah, Alisa, Najwa,
Yes.
press the thumbs up. So is the video is clear or not? Right, I hope so. I think yes, thank you. Right, so I will proceed.
For this specific experiment, you'll need several laboratory apparatus. The burette, pipette and its rubber bulb, measuring cylinder, conical and volumetric flask, filter funnel, beakers, spatula and glass dropper. As for the chemicals, we're going to need areochrome black tea indicator, your water sample, buffer solution of pH 10, diluted hydrochloric acid of 20%, sodium hydroxide, ethylene diamine tetraacetic acid or EDTA for short, calcium carbonate.
Okay, actually we have one more chemical. Okay, if you already opened the manual with you, we supposedly we have the magnesium chloride with us. Later on, it's actually been introduced later on. So for the intro, we actually forgot to include it. Okay, so we have another one, which is the magnesium chloride.
As well as an analytical weighing balance as the instrument. Firstly, you need to weigh about 0.25 gram of calcium carbonate using the analytical weighing balance. Make sure that the balance is on a sturdy and stable surface, and do not forget to close the glass doors on both sides of the balance. Next, press the tare button until you get the displayed value of 0. This is important in order to avoid any erroneous measurement. Then, using a clean spatula, scoop a small amount of calcium carbonate and cautiously transfer it into the beaker until you get about 0.25 gram. Remember, please do not return the excess chemical into its original container, as this may cause contamination. Should you have excess calcium carbonate on the spatula or...
Okay, so this is the amount of the calcium carbonate that been taken in this study. So please jot that because you need that to calculate the in the formula later on. Okay, have you got that? 0.2507 gram. Okay, may I proceed? Okay, thank you.
any other chemicals for that matter, you may simply discard it in an appropriate and labeled waste container. Next, weigh about 1 gram of EDTA and 0.0.
Okay, here is the weight of EDTA. Okay, 1.0008 gram. Okay, make sure to jot it down the data. If not, you are not able to perform the accurate calculation later on. Okay.
0.025 gram of magnesium chloride hexahydrate.
Okay. Right now is the magnesium chloride. Okay, hexahydrate. 0.025 gram. Okay. Okay, before that, I would like to ask, okay, what is the function of the EDTA in this study? Okay, anybody guess? Okay, anybody? The titrant, yes, the titrant is the EDTA, but what is the function of it? What is the characteristic of the compound? Yes, it's stimulating, yes, because it will form the ligand with the metal ion later on. Okay, so that is kind of accurate because for the complexometric titration, okay, as the calcium ion presence as the ion, we need to chelate. We need to bond with the ligand, which is our EDTA. Okay, how about the magnesium chloride? Okay, so I think I leave the question, okay, for you guys to discover in your report later on. What is the function of the magnesium chloride? Why we need that in our experiment? Okay.
For preparing the calcium carbonate solution, you'll need the 0.25 gram of calcium carbonate that you had just weighed and diluted hydrochloric acid, a small filter funnel, and a clean 250 ml of volumetric flask. Next, add dropwise of diluted hydrochloric acid into the beaker containing the calcium carbonate. Be sure to cautiously stir the mixture in order to dissolve the solid completely until a colorless solution can be observed.
Okay, can anybody guess what is something wrong in this slide of video? Can anybody guess what is the mistake living in this video? Can anybody guess on it? Stir with spatula, not entirely correct. Is yeah, we're supposed to use a spatula, but I think stirring by doing this method is also okay. But what is the mistake actually? The largest mistake, the big mistake that we actually leave in the video. Yeah. All right. Thank you, Su Hui Ling, Atika, and Hu Wenying. That's correct answer. It's not wearing a pair of gloves. Okay, when we're handling the chemical, regardless its concentration, we should wearing glove. So what is the other mistake other than we're not wearing glove? Can you guys guess? Put excess chemical back. Not entirely true, because the dropper is what we call assigned to that particular chemical alone, so nothing wrong with it. So when we handle the acid, can we use this? Can we handle it in the open space, or we need to perform it somewhere else? Where is somewhere else? Correct. Fume hood, or we can call as the fume cupboard. So I need you guys to be able to understand what is the mistake that we actually leave in the video. But of course, our instructor over here is particularly expert, so he knows how to handle it very well. But please, if possible, never do mistake like this. Okay, so we just left the mistake over here. Just want to make sure that the student can point out the mistake. Okay, let's proceed. So basically, the instructor over here put literal by literal, minimum amount of so until we get a clear solution. So okay, so my next question is I would like to ask why we need to use only minimum amount of HCl. Why we cannot just what we call put bluntly 10 milliliter or 20 milliliter of acid? Why we need to put very minimum amount of hydrochloric acid in this experiment? Okay, I hope that you can try to answer the question in your report later on. So, but if anybody want to guess what is the answer to that, can you guys try to explain it? No. Okay, so I think I will just left the question for you guys to answer in your report later on, or maybe just include it in the report. So you guys need to understand why we need to use very minimum amount of hydrochloric acid.
Make sure that you have completely dissolved all the solid samples, including the ones at the wall of the beaker.
Okay, so Mr. Daniel, the instructor this time, okay, is continue the process by using the spatula. Okay, by using spatula properly, what we call put some friction of it to make sure everything dissolves properly.
Then, using a clean filter funnel, transfer the solution into the volumetric flask. Make sure that you rinse the beaker for at least 3 times to ensure that all of the solution is transferred into the flask.
Please make sure next time you rinse, transfer into another container. You next need to do some rinse, okay, process about 2 or 3 times to make sure all the compound of interest properly transferred.
After that, you may further dilute the solution with distilled water up until it almost reaches the calibration mark, preferably about 3/4 of the flask.
Okay, my next question, why we need to prepare the chemical and dissolve it in the volumetric flask? Why we cannot just prepare in the beaker? Can anybody guess? I think the answer is very simple. To get the exact amount, okay, that's good. So Hulun to get the exact or accurate amount. Okay, if you are using the beaker, is that not correct or not exact? It's same because one standard solution. What happens if we only prepare in beaker? For example, we use the beaker and we just use the meniscus level we have on beaker. Why we not only use the conical flask to prepare the standard solution? Why we use the volumetric flask? Okay, I think it's already answered by Suhilun to get the exact amount, or we want to have very accurate concentration of our standard solution. I think that's the answer for it. So we cannot just simply use beaker or conical flask because the accuracy of the apparatus is less compared to the, it's not accurate compared to the measuring, what we call the, what we call this, volumetric flask. Okay. Okay, we continue. Okay, can you observe another mistake in this video? Can you guys guess? Can any of you guess? Where's the other mistake that we can point out in this video? We'll get parallax error, or I don't think we need to go into that error. It's not parallax error. Not cleaning up. I think the volumetric flight is clean. Okay. Okay, I will point out the mistake. Okay, which is the way the person handled the dropper. Okay, the dropper never should be handled upside down like this. Okay. Why is that? Can anybody guess? Prevent contamination. So we may get some liquid goes inside the pump or bulb over here, and then the contamination may transfer into this volumetric flask. So we want to avoid any possible contamination. Okay, but I believe during this time it's a new dropper, so it's there is no liquid presence in the bulb. Test with the new dropper.
Using a dropper, slowly add more distilled water until it reaches the calibration mark. Now remember that the meniscus should be viewed at eye level. If too much of the distilled water is added, the solution must be discarded and a new solution should be prepared from the first step of this procedure. Then firmly cap and mix the solution thoroughly. And lastly, make sure that you label the volumetric flask accordingly. Now, for preparing the disodium EDTA dihydrate solution, you'll need about 1 gram of EDTA, 0.025 gram of magnesium chloride hexahydrate, 4 pellets of sodium hydroxide, filter funnel, glass dropper, and of course the volumetric flask. Using an appropriate amount of distilled water, dissolve all of the weight chemicals and transfer all of them into the volumetric flask. Make sure that the all weight chemicals have been completely dissolved. As usual, upon transferring the chemicals, rinse the individual beakers with distilled water and transfer it into the flask.
Okay, basically this is one of the common mistake actually done by the student where they forgot to rinse, okay, the solution where they transfer from another container to another container. So that is one of the common mistake. Okay, what happened? We don't get the accurate amount of the analyte of interest or compound of interest on our next container because we forgot to rinse on the previous container. Okay, that is one of the common mistake. Okay, that should be avoided by us all.
Then, cap and mix the solution thoroughly. Lastly, transfer the sodium hydroxide solution into the beaker and don't forget to rinse the beaker. Again, cap and mix the solution thoroughly.
So I have another question for you guys because you guys doesn't have any questions for me. Okay, make sure you guys to be able to understand why we need the sodium hydroxide in this experiment. Why we need sodium hydroxide to be added mixed with the EDTA. Okay, make sure to include that in the report.
Similar to the previous solution preparation, further dilute the solution with distilled water up until it almost reaches the mark. Then, you may use a dropper to slowly add more distilled water until it reaches the calibration mark. Make sure to label the flask accordingly. For the second part of the experiment, it will involve the standardization of the Edta solution using the titration technique with known amount of calcium carbonate solution that you had just prepared earlier. Here, we need about 3 250 ml of conical flasks, 200 ml of beakers, prepared calcium carbonate and disodium Edta dihydrate solutions, aerochrome black tea indicator, burette clamp to the retort stand, filter funnel, and $25 ml of pipette and its rubber bulb. Firstly, you need to rinse the burette with the disodium Edta dihydrate solution, preferably about 3 times, and discard the solution in the collection beaker.
Okay, there actually 2 factors, okay, why we need to do the pre-cleanup for this. Okay, I think you guys can watch the video of the basic introduction of the titration. Later on, we will provide in the e-learning why we need to do this.
up the burette with the solution and do not forget to take the initial reading.
Okay, before that, I just want to ask, is that necessary we need to fill until 0 mark? Or we need to start from 0? Is it necessary or not? Can anybody guess? Nobody want to guess. Very simple answer, not taking your time. Okay, Siti Aisyah said that's not necessary. Al-Zahra, we need to start from a mark to measure the volume. Okay, so two different opinion. Not necessary, but it's easier to read from 0. Okay, the answer is really not necessary to start from 0. But if you can get close to 0, I think it's okay. But it's not necessary to start from 0. Teh Yiling, you want to try to discuss why you think that it's necessary? Okay, I think it's not necessary. Okay, it's definitely not necessary to start from 0. But if you start from 0, of course, later on, if you want to perform the calculation, you will get a very nice value. Okay, but it's not really necessary. It's just necessary just to put maximum amount of the titrant, okay, inside of the burette, okay, before we start the titration process. Okay, because we don't want that we don't have enough titrant for the titration. But it's not necessarily to start from 0. Okay. So I leave the reading here. Okay, how many decimal places for the burette? How many decimal places for burette? Anybody want to guess? Teh Yiling said 1. Wah, Dashika Sugumaran said 3. Okay. Azhar Muhammad said 4. Siti Aisyah said 2. Okay. Bakri Hakim 2. Okay, the most accurate answer for the burette for the decimal place is 2. Okay, 2 is the decimal places you are allowed to what we call write in your table of data. Okay, so you can write as 0.1, you can write as 0.15. Okay, depending on what you believe the nearest reading value. But it can go to 2 decimal place with the 0.05 reading of interval. Okay. So in your opinion, what is the nearest value for this reading? Can somebody try to write in the chat? Tak ada siapa nak tulis 0.02. Okay, how many what we call level before we can reach to 1 over there? There are 10 levels. So if you divide it by 10, it's supposed to be, yeah, correct, Al-Zahra. But the decimal place is not correct for Siti Aisyah, Sim and Najla. So be careful with the decimal places. It's supposed to be either 0.10 or 0. I'm not sure, but I don't think that it's 0.15. I think the nearest value is 0.10. Okay, So let's proceed.
Then, rinse the pipette with the calcium carbonate solution. And pipe out an accurate amount of 25 ml of the solution into each of the conical flasks. Using a measuring cylinder, add about 1 ml of buffer solution of pH 10 into each of the flasks.
So here is another question for you guys. Okay, maybe not necessarily to answer right now, but please discuss in your report later on why we need to put buffer. Okay. So for the buffer, it's not necessarily we get the accurate amount. So it just more or less or about 1 ml of buffer.
And add add about 2 to 3 drops of Aerochrome black tea indicator.
Okay, make sure to describe as well what is the function of indicator, okay, how it actually contribute in the study. Okay.
Swirl the flask gently. Place the flask beneath the tip of the burette, making sure that the tip does not touch the walls of the flask. Slowly open the stopcock so that the titrant drips out of the burette drop by drop.
If we can observe the color of solution over here, it is like red wine in color. So let's say if you're doing the real experiment, if the color you're not getting in about a red wine, maybe you get blue in color, so it means something wrong with the calcium that you prepared. Okay.
You may gently swirl the flask while you're at it. Once you notice a permanent color change from red to blue, close the stopcock, as this means that you have reached your end point. Be sure to take note of the final reading, and do not forget to repeat this step for the remaining 2 flasks, and make sure to fill up the burette again before you begin titrating.
Okay. Previously, the initial reading is 0.10. So now is the first final reading for the flask number 1. Okay. Give us thumbs up if you get the value. It's already share the value with you guys. Okay, is that correct? 19.3. So I hope that you guys have your own reading. I'm not really sure it's accurate or not, 90.3. So I think we should proceed. Okay. Remember, you are allowed to have until additional of 0.05 value. Okay, here is the second initial reading. Again, give us thumbs up if you already get the value. Or you can write in the chat if you. Shika, thank you. Okay, I will proceed. Okay, it's up to your eyes actually, how actually you reading the value. If you reading the value wrongly, and I think that I can help you. Okay, we actually just added the extra drop of indicator because previous time we not actually see clearly the richness of blue color. Hopefully this time we get very good color, blue color observation. Yeah, I think this time is better compared to the previous one. We can see more richness of blue color. We can put extra 1 drop of the indicator, maybe 3 to 4 drops. Okay, no problem, but don't put too much. Okay, so when the original color, when the indicator form a ligand with the metal ions, it will be a red wine in color. So when actually the EDTA has bond with all the metal ions, so the areochrome black tea will turn back to its original color, which is blue. So some of the mistake did by the student, okay, they actually stop at purplish color. So it's not correct actually to stop at purples. We need to stop the titration when only you reach the blue in color. Okay, here is the final reading, okay, for the second titration of the standardization process. Okay, can anybody of you give a thumbs up if you already have the value with you, jotted down with you? Okay, so I will proceed. Okay, this is the initial reading for the third titration for the standardization. Okay, and you guys give a thumbs up after you get the reading of the third initial value. Okay, I'm not sure if the value you put over there is accurate or not. Hopefully it's accurate, because of course I will reflect with my own data later on. All right, and proceed. Okay, I would like to explain. Okay, actually the table level, the height of the table is not really suitable for any experimental, but we don't have the proper area of the experiment. So please forgive us on the what we call the non-comfortable situation during the experiment process. Okay, this is the third final reading for the standardization process. Okay, you guys can write over there. May give us thumbs up if you have seen the value or you get the data. Okay, since somebody already put the data or the value on the chat room, so I will proceed.
Finally, the last part of the experiment, you'll need a 10 ml pipette and its bulb, 200 ml of beakers, your water sample, 3 conical flasks, aerochrome black tea indicator, buffer solution of pH 10, and a measuring cylinder.
Okay, previously we have done on the standardization process. Now after we have done the standardization process, so we proceed to sample. So anybody want to guess why we need to do the standardization? Okay, can any one of you try to guess? So because we don't have a lot of Q&A session, so I just want to ask for the time being, why we need to do standardization process before we can proceed with the real sample. No, nobody want to guess. Okay, later on, maybe after we finish the experiment, I will ask again.
Firstly, transfer an appropriate amount of your water sample into a clean beaker and pipette out about 10 ml of the sample and subsequently transfer it into the conical flask individually.
The process is similar to the standardization, but in the standardization, we use 25 ml of the calcium carbonate, which is the known concentration of calcium carbonate solution. But for the sample, we only use 10 ml of the sample solution, okay, to determine the concentration of calcium inside of that particular water sample.
approximately 1 ml of buffer solution and a few drops of aerochrome black tea indicator into each of the flasks. Then you may proceed with the titration process using the disodium EDTA dihydrate solution prepared earlier until you observe a color change of red to blue. Be sure to take the initial and final readings.
Okay, here is the initial reading for the water sample analysis. Okay, again, here is the initial reading for the first replicate of the real water sample titration. Okay, anybody want to put in the chat room? Okay, I need second opinion at least before I proceed. Okay, so we have two kind of opinion. You can choose either one. So I will proceed.
Similarly, repeat this step of titration for the remaining two flasks.
Okay, here is the here is the final reading. Okay, for the first titration process of the real water sample. Maybe it come from drinking water. So anybody want to put in the chat room? I need a second opinion. Okay, at least. Okay, thank you. Okay, please use this value for the initial reading for the second replicates. Okay, please use this value, okay, the value of the final reading for first replicate as the initial value for the second replicates. Okay, here is the second reading. Here is the second final value for the second replicates. Anybody want to put in the chat room? I need at least 2 person right in the chat room. Okay, so I shall proceed. Okay, sorry. Please use the final reading for the second replicates as the initial reading for third replicates. Okay, again, please use the final reading of the second replicates as the initial reading for the third replicates. Okay, here is the final value for the third replicates. The final reading of the third replicates. I need at least 2% to write in the chat room. Okay, thank you.
And you're done. Thank you.
Okay, first of all, I would like to give some acknowledgement to Mr. Daniel, the instructor who performed the experiment. Okay, secondly, to the narrator, which is Dr. Aida Rashida Azman. Okay, the lab assistant, Mr. Faiz, and of course, the what we call the assistant, okay, Dr. Akmali and Dr. Afiq, okay, in guiding this video. Okay, and of course, our master student, which is Abang Lokman, okay, for actually editing the video. Okay, that's it for experiment number 2. So I will stop sharing. So I will provide some times for the Q&A session. Okay, if you guys have anything to ask, okay, I will try to answer. If not, okay, we can discuss together and we will include some of the value of the question inside our report. Is there any question? Oh, we have Mr. Daniel is actually with us. Cik Daniel want to add anything? Ada, Dr. Aida, you want to add anything?
Tak ada.
Tak ada, eh? Thank you, Dr. Aida. So, do we have any question from the student? So, I hope that you guys be able to determine the concentration of the calcium into kind of value, okay, which is in the term of molarity, okay, and also in term of part per million, okay. So make sure to show us the value in mean, standard deviation, and of course, lastly, relative standard deviation. That is the thing that you need to find. Make sure to include the thing that I asked in the question. So I think that is the thing that we need the student to be able to discuss inside of their reports. The importance, why we need to have these certain chemicals, okay, why we need to add this chemical, okay. That is the kind of what we call discussion, okay, we expected from the student. Ada soalan tak? Can anybody can just give their opinion about this experiment? I need just one of you to give some opinion before we end the session. If not, I will not end the session because I need some of you try to give some opinion about this experiment. Okay, maybe for the sake of our improvement later on in the future as well. Can comment anything. Okay, can we have somebody? Okay, we have a lot of participants. We have a lot of students over here with us. I believe we reach about hundreds students. So I need just one of you to give some opinion regarding of this experiment. What do you think and what can be improved maybe? You would like to discuss as well. You would like to point it out. Okay. Janganlah malu-malu. Baru tahun 1. Tahun 1 ya. Okay, Najla Ghazali asks us the standardized step is to get the average. Okay. So you guys need to understand why we need to do the standardization. Okay, it's not to get average. The answer is not to get average. It used to get something else, but I don't want to give the answer. Lim Chi Keng calibration process is kind of close, but not really accurate to the real answer. To know the exact concentration of solution, what is the solution? What solution do you mean? You want to know the concentration of what? I don't want to give the answer, so you guys need to discuss. I give you guidance. Okay, what is wrong, what is not. But it's not for getting the average. The average is the value that we need to calculate, but the purpose is something else. It's kind of the calibration process, but it's not really accurate. Want to know the exact concentration of solution, what is the solution? What solution? Explicitly. Okay, anybody guess? Okay, in the first step, for the standardization process, you can calculate the concentration of calcium. What is the other solution that you do not know its concentration? Water is the third step. Okay, the first step you need to do the standardization, right? Okay, in the standardization, you have already know the concentration of the calcium carbonate. You can calculate by using its weight, 0.25 gram if I'm not mistaken. Okay, and then you can just divide everything, get the value, and then you can get the concentration, okay, in terms of maybe mole per liter, maybe PM. Okay, but what is the concentration that you didn't know? Exactly. Right. We want to standardize the EDTA solution. Because in EDTA solution, we have dihydrates, and then we mix with the magnesium chloride and also some of the sodium hydroxide. So we need to get its accurate concentration. So by using the standardization, we can know the concentration of EDTA. If you don't get the concentration value of the EDTA, you may not be able to get the concentration of the real sample. Anything else? So I need one of you to speak, give your opinion. Just a short speech, about 30 seconds or 50 seconds also okay. I just need one of you. If more, it's better. Ada tak nak bagi pendapat? Janganlah malu. Dah nak habis ni. Tak habis ni. Tak ada siapa nak bagi pendapat ni. Macam mana nak habis session ni? Cakap je apa-apa. Nak tanya soalan pun boleh. Tapi saya perlukan... Hello?
About the class, right? for this
Okay.
session. The video was okay. It was easy to understand.
Mhm.
But taking the reading was a bit tricky and
The reading
confusing.
is a bit tricky. Yeah, we understood. I also not sure. I think we already took a picture. Maybe it was somewhere because we need to get the picture directly from the video. I think there's something wrong with that. Okay, I understand that. We are really sorry about that. I'm really sorry for that as well. But it's a bit tricky. That's good for your eyes, right? Thank you.
Yeah.
Okay, Yiling have some question. I have a question. The indicator change color from red to blue, or it's light blue or dark blue. Okay. How can I answer that? It changed to red to blue, but the richness of the blue depends on the amount of the indicator that you add. If you add few amount of indicator, so you will get light blue. If you get maybe extra amount of the indicator, you will get the dark blue in color. Okay, that is all that I can say. Okay. Am I answering your question, Teh Yiling? Right. Ada soalan lain lagi tak? Kalau tak ada, okay. Saya ucapkan terima kasih. I would like to again to say thanks to the team, especially Lokman, Dr. Aida, Encik Daniel, Dr. Akmali, and of course from the team A, Dr. Faizwan, Dr. Najib, Dr. Has, and others. Okay. So tomorrow you have another session for experiment number 3, and Thursday, the last day, you have another session with Encik Daniel. So stay tuned until the last day of the session. Okay, I think that's it. Okay, if you have any question, you can stay. If you don't have any question, you may be dismissed. Okay, thank you so much.
Thank you, Doctor.
Thank you. Okay, tinggal ni ada soalan ke? Oh, sial Lokman, tak tidur gitu. Lokman dah tidur ke belum? Asyik tidur ke? Tahniah Dr. Faizwan dapat geran. Kecewa. Kita cuba lagi. Okay, bye semua. Kalau ada apa-apa, just beritahu pada Dr. Faizwan lah. Kita orang akan cuba menjawab.